This is your tech news briefing for Friday, October 7th. I'm Zoe Thomas for The Wall Street Journal. This week, the Nobel Prize in Physics was awarded to three scientists, Alea Spare, John Clauser, and Anton Zeilinger, for their work on quantum physics, and particularly for helping lay the foundations for quantum computing. Unlike the bits that power traditional computers, quantum computers use quantum bits, or qubits, to run algorithms. That makes them faster and more efficient, and that's something businesses and governments really want. Joining us to explain the Nobel winners' discoveries and where they're taking the world of computing is our science reporter, Eric Niiler. Hi, Eric. Thanks for joining us.
Good morning. How you doing today?
I'm doing great, although maybe a little bit confused with this topic. In the simplest of terms, can you kind of describe to us why these scientists won?
Sure. These scientists did some experiments decades ago that really opened the door to something called quantum computing. Quantum computing promises to solve all sorts of complex problems that existing supercomputers really can't handle. That could include the folding of proteins in molecules that can be used to discover new drugs. That could be understanding how the Earth's climate is changing and all the variables and temperature and weather and so forth that influence that. It could also mean maximizing shipping routes for hundreds of tankers across the world.
Describe to me this concept of entanglement, because it seems to be pretty critical to what we're understanding here.
So this is when two or more of these subatomic particles sort of share a destiny. So whatever influences one happens to the other, and vice versa. Albert Einstein referred to this phenomena famously as something called spooky action at a distance, because the entanglement ties the states of these particles together even when they're separated by great distances. So what these scientists did was really understand something in the fundamental concepts of entanglement and how it works and what these mysterious interactions, what influences them and what makes them happen.
Why does that matter for making computers work faster?
So understanding entanglement has helped scientists today better able to sort of manipulate, control, and work with these subatomic particles to transmit information, to run algorithms, for example, much more efficiently than supercomputers that are using this strings of ones and zeros and bits.
There's also this opportunity for quantum encryption and also for using the concept of entanglement to help with secure communications. How would that work?
One of the things with qubits is that from a cybersecurity perspective, if a hacker tries to observe them in transit in their super fragile quantum state, it collapses, and so the hacker can't really tamper with these qubits without leaving behind a telltale sign of their activity. So some companies have already taken advantage of this property to create new networks for transmitting sensitive data based on something called quantum key distribution. So this is still an emerging field, but the promise of quantum communication, secure transmission of data, has really been opened the door by these experiments that were done decades ago by these three scientists.
How far along is the development of quantum computing? I mean, when might we expect this to be just part of our world?
Right. IBM does have a quantum computer. They are running some applications on it. One of the things is, in addition to just technical issues of computation and so forth, it requires a lot of energy to keep that processor so cold. I spoke with someone at IBM, and they are working with clients such as Boeing and Exxon to help them with their data needs, to look at large patterns of data that can help them. So there are some applications being run. It's not ready for prime time. What Jerry Chow, an IBM fellow and director of quantum infrastructure at IBM, told me said that we're not at the point where quantum computing provides a real business advantage, but they're trying to unlock value over time. So it's still on the horizon, but there's a lot of promise, and there's actually quite a bit of money going into quantum computing right now.
All right, that was our science reporter, Eric Niiler. Thanks for joining us, Eric.
You're welcome. Great to be with you.
And that's it for Tech News Briefing this week. Our producer is Julie Chang. Our supervising producer is Chris Zinsley. And I'm your host, Zoe Thomas. Thanks for listening and have a great weekend.